Okay. Let's go. So the exam is, you can find it under assignments, kind of down here at the bottom. You go to quizzes, as I kind of mentioned last week, kind of the last quiz down here. You'll notice it's out of 105 points. It's actually only going to be graded out of 100. There's a kind of a bonus question where you can get some additional information. Additional points. And so you'd be able to get 105 out of 100 if you get everything correct. You can start the exam at any point today or tomorrow. Once you start, you have an hour and 20 minutes to complete it. It's 19 questions plus the bonus question, and then kind of a short answer that has 3 questions associated with it. If you have any kind of technical problems at all, once you start the exam, you're not using kind of the lockdown browser, but for some reason, I don't know, it exits out and accidentally submits without you completing like half the exam, email me and let me know immediately, right? And I can maybe try to get it so you can kind of pick back up wherever you left off. Right? Other than that, are there any questions for me before we kind of jump into just doing some more practice exam problems? Let me pull the chat up too. Yeah, you could go back through some of the online quizzes. I would say some of the questions are probably might be a little bit easier than what you would see on the exam, but it is a good idea to kind of go back through if you're wanting some additional practice. Some of those online quiz problems would be some great additional practice to go through. Any other questions before we kind of jump into things here? All right. So are there questions on either practice exam A or B that anyone has specific questions on? If there are those, then we'll kind of start there. No one has any questions? So everyone's good to go.
I mean, I had questions. Like I was struggling with the A one on Excel.
Okay.
But I wasn't able to.
Yeah, let's go through. It's a good one to go through. Let's do on practice exam B. Well, actually, let's just work through 11 through 13. All right, so 13 will be one where we have that base, but kind of the general setup, all right? So we're told here, there's concern over steroid use in baseball. Manufacturer claims that the drug test will show a positive result given that the athlete is using steroids or uses steroids with probably a 0.95. So the way I would approach these, for the video here, I'll kind of increase the size of this and kind of work along the side of these. So I'd first write down what we're given. So this one we're told, given that the athlete is using steroids. So I'm going to be thinking about given that the athlete is using steroids, the probability that this test comes back positive, right, is 0.95. Okay. So given that this athlete is using steroids, remember the given is this conditional line. So whatever you're given goes on the right-hand side. Given that they're using, the probability the test comes back positive is 0.95. That's the first thing that we're told. The next thing we're told is, however, the probability the drug test shows positive given the athlete is not using is 0.01. So now we've got, given that they're not using, the probability that we see that test come back positive is 0.01. Right? The final piece of information we were told is recent, articles suggest that the probability of random baseball players using steroids is 0.15. So the probability, if we chose someone at random, the probability they're using is 0.15, which anytime we're given kind of like the probability of a state of nature, we should automatically know the other state. So if the probability that they're using is 0.15, the probability they're not using would just be 0.85, right? Because we know these two probabilities have to add up to 1. Okay? So keeping all this in mind, like this is the information we were given from the problem. So the very first thing we're going to do in the problem here is identify what are we looking for. So in 11, we're asked for the probability that the athlete is using steroids and test positive, right? So the probability that they're using and the test comes back positive. Now, another way of thinking about this, if I'm writing this down by hand, instead of putting in the word and there, I could use this kind of set symbol, which represents the intersection or these two things, or the and, right? It was kind of what we said. We read it as this and this, okay? So I'm gonna hide myself for a second here. We're gonna pull this open. We're on number 11 of that second practice exam. I'm also then going to, thought I had this pulled open already, but I didn't. Use this formula sheet. Okay. So I go over here on my formula sheet. I can see that I can rewrite the intersection of two events as the conditional probability times what I'm conditioning on. Okay. So here I've got the intersection. This is my A, this is my B. So I'm just going to, I'm going to try to put this over so we can see it as we're writing this out. We're going to write this out as a conditional probability, so the probability that the test comes back positive, given the person's using. Right, here's my A, here's my B, so I flip them, write that conditional probability, multiplied by the probability of whatever I'm conditioning on, which here I'm conditioning on the fact that they are using. So once I have this, now it's just a matter of going to the information that we were given originally. I can get this to be bigger, so I can point these out to you. All right. What was the probability that they were using? 0.15. Given that they're using, what's the probability that the test comes back positive? Given they're using, the probability the test comes back positive, 0.95. Right? So we plug those in, right? That 0.15. This is 0.95 times 0.15, the way I had this written before. If I do that, it should end up with, I'm guessing it's about 0.143. Yeah, then my calculator. So that one was a little bit easier. That was kind of finding the intersection with all this additional information. Now, what if, and I'll skip 12 here because I mean 12 is really the same idea. It's just what if they're not using? So now it's everything would be exact same. It's just now what's the probability they're not using? Let's see this chat before I keep going. Okay, I'll mention that in just a second. It's a good question. So it's really, oh, come on. So this is really the same question as 11. It's just now what's the probability they're not using and test positive. So we literally could actually take the exact same equation, but everywhere we were saying using before, now we're saying not using, right? And it shouldn't be that much more difficult because we look at the probability that they're not using, that was right here. And given that they're not using, the probability that comes back positive, that's right here. So now it's just a matter of grabbing those. So our equation there, it's all to be on one line here. Probably helpful. So we just plug in our values there, which are 0.01 times 0.85, which if we round to that third decimal would be at 0.009, right? Or 0.0085, which rounds up to 0.009. Okay? So any questions on that one before I address the question that was asked in the chat? Okay with that one? So the question in the chat was, when do we use the special conditions? So the special conditions on this formula sheet, when we wanted to find the union of two events, we said typically that's add up the probability of both events, but subtract the intersection because you double counted it. However, if two events were mutually exclusive, we knew that the intersection was 0 and that formula would simplify down to just this. We also said if I want to find the intersection, you could write this as the conditional probability of B times the unconditional probability of A. Well, if they're independent events, the conditional probability of B is the same as the unconditional, so you could just substitute that in. So this only holds when the two events were independent. So it might be something good to like kind of write down next to the formula sheet. You could download this in Word and kind of edit the formula sheet by typing stuff in there. You print it out and write down next to it. You can kind of insert word boxes in Word instead of like actually typing the words on different lines, because it might kind of mess with some of the alignment. You could just insert some kind of words, let me see. So like insert shapes and then just do like a text box. So that way it doesn't like shift all the formatting around. And you can do that in the formula sheet so that you can remember when those special conditions apply. Any other questions before we kind of move on to 13? So yeah, so 13 is probably a pretty tough one, right? So this is going to be kind of that Bayes equation. So given that the test comes back positive, what's the probability the athlete does not use steroids? So we're told that given that the test comes back positive, what's the probability the athlete is not using steroids? So not using, right? Because we know when we see these positive test results, there's going to be some people that tested positive and were using steroids. Some people who tested positive and were not, right? So given that we see a positive test result, you know, what's kind of the ratio of those two groups that make up that positive test result, kind of larger group? Well, anytime I see a conditional probability, I go to my formula sheet. If I try to write it out as just the intersection divided by what I'm conditioning on, notice what I'm conditioning on is just the probability that someone gets a positive test result. That wasn't one of the pieces of information I was given. So if I try to just use the multiplication rule, I'm going to figure out here that I don't have those probabilities, and I need to break it down even further, which is down into Bayes' equation. All right? So now that I know I need to use Bayes' equation, probably an easy thing a nice thing to start setting it up is, let's just identify what our S is. It's the first thing. And then what we're conditioning on, that's our outcome of the, right? That's our E, outcome of the test. Okay? So I can rewrite this. I'm going to insert an equation here just to make it look a little bit pretty for us. So the very first thing I want is the probability of S. So the probability that they're not using times the probability of E given S. So the probability that the test comes back positive given S, which we have defined as not using. Actually, let me make this a little bit bigger here. Now, the first part of that denominator, notice, is the exact same thing as the numerator. So I'd basically just be writing this out again. I'm doing this by hand. First part of the denominator is exactly what I just wrote in the numerator. So to save myself a little bit of time, if I can select this without selecting the whole thing, I'm going to write this as the probability of, oops. So I just have the exact same thing as the numerator, but now I have the second component in the denominator, which, oops. The probability of S complement. So if S was that they weren't using, S complement is that they are using, right? Times the probability of E given S complement. Well, E, we had just said was testing positive, so that the test comes back positive, given S complement. Well, if our S was that they weren't using, we said S complement was just that they are using. Okay? Let me see if I can get this all to be the same size so we can see this all in one line. Okay. Now from here, it's going back to the information we were given and just plugging things in. So notice, I'll kind of start plugging the values in for you here. I'm going to pop up this in the corner so we can see. So the probability that someone was not using was 0.85. So 0.85 times, given that they're not using, the probability the test came back positive. So given they're not using, the probability the test came back positive is 0.01. So 0.01. Now divide by, well, that's the exact same thing we had there in the numerator. So I could just kind of type or write that out again. Plus the probability someone's using, well, the probability someone is using is 0.15 times the probability that given they're using, the test comes back positive. Given they're using, the probability the test comes back positive was 0.95. Right? Now I've got all my values plugged in. It's a matter of kind of getting that entered into my calculator. Okay? I think if I do that, I think I get 0.056 if I look at the answer here. Okay? And really what this is saying is, notice this group up here, this is the exact same thing that we had for problem 11. This is just the people who are using and test positive. Sorry, not 11. This is not using. So this is number 12, right? Probably that someone's not using and they get a positive test result. And then divide that by the people who are getting a positive test result and not using, plus the probability of people who are getting a positive test result and using. So it's almost like saying, you can think about this as numbers, right? Here's the people, instead of probabilities, think about frequencies. Here's the people who aren't using, the number of people who are using and test positive, divided by the total number of people who test positive, which are composed of people who test positive and are not using, plus the people who test positive and are using. That's kind of the general idea of what Bayes' equation is trying to do. Kind of look at this ratio of, given that we're looking at someone with a positive test result, how many people with a positive test result would not be users? Divide that by the total number of people who will be users and not users, but both have positive test results. Okay? Like I said, I think if we enter this into our calculator, we get 0.056. Okay? Any questions on that one before we keep moving? And if you want more examples of Bayes' equation, Bayes' theorem examples, there's an additional video, which is a good thing to look at before the exam. Has some really relevant examples to what's asked in the exam, wink, wink. So it might be a good idea to look over those. Okay. Any other questions you guys want to kind of go over? Otherwise, I'll try to kind of pick and choose a few. 13 on part A. So I would go over 13 on part A. Here's what I'll say. I believe we did that Friday. Right, that was the Bayes' theorem question. Oh, 13. No, okay. Yeah, I'll do 13, and then we'll go to number 5 real quick. So practice exam A. Oh, yeah. Okay. So this is kind of big, but we'll make this work. So here we have kind of this Venn diagram. What do we know this rectangle kind of representing? The entire experimental outcome space, right? So we know the area of that rectangle should be 1. It represents every single possible outcome. So if I add up the probability of every single possible outcome within that space, it should add up to 1. So I can do this one of 2 ways. So I'll describe to you what I think might be the easier way first. So if I look at this shaded light blue area, and then I think about the area that's in these circles, those 2 areas have to add up to 1, right? Because this shaded light blue area plus all the area in the circles, that fills out the entire rectangle or the entire experimental outcome space. So I'm told that light blue area is the intersection of the complements. Okay, fine. I'll always be told that. But I'm also told it's 0.1. So what do I know that the area in the circles has to be? Yeah, just 0.9, right? Because I know this entire area is 1. If I take out this light blue area, which is 0.1, what I'm left with is 0.9. Okay? So this is where I'll start thinking about it that way. So if I know the area in the circles is equal to 0.9, now I need to think about, okay, what is the area in those circles? Well, that is, I'm either in circle A or I'm in circle B, or I could be in both. So I'm either in A or I'm in B. Well, that's really just saying the union of those two things, right? Now, I could have started out thinking about it this way. 1 is equal to the probability of what's in those circles plus what's not in those circles, right? Here, I'll switch real quick so it's on the video, it's easier to see. I could have started here and then said, well, okay, well, this is 0.1 and then move that around. But I think it's pretty easy to see from that visual that what's in those circles, that area would have to have been 0.9. But I could have started up here, right? Plug 0.1 in here because I don't think you can see that for you. And now kind of do a little bit of algebra, and I'd be right here. Okay? Now, if I look at my formula sheet, when I'm looking for the union of two events, maybe, there we go. The union of two events is simply going to be add up the probability of both events, subtract the intersection, okay? So I can rewrite this as 0.9 is equal to the probability of A plus the probability of B minus the intersection of those two events. Well, I'm told what those are. All right, the probability of A is 0.4. I don't know the probability of B, but the intersection is 0.2. Okay. So now I'm just going to plug in 0.9 is equal to 0.4 plus the thing that I don't know minus 0.2. And now it's just a little bit of algebra, right? 0.4 minus 0.2 is 0.2, so I'll subtract 0.2 from both sides. And I'm left with 0.7 is equal to the probability of B. Okay. Any questions on that? Make sure there's none in the chat. Does that kind of answer 13? Hopefully. Unless I hear otherwise, I'll assume it did. So that's how you would work through one like that. So I guess we got what, 0.7 here? Okay, number 5. Oh, so whenever we have missing values, right, this is where we said we can add across the rows or down the columns, right? So I know, think about it this way. If somebody is over 55 and wants marijuana legalized, and I added that to the number of people who are over 55 and didn't want marijuana legalized, I would just have everybody who's over 55. Right, or older than 55. Remember, these contingency tables, just like in that Excel problem, you can start with frequencies. So even though we're dealing with probabilities, you can still think about these as like, I'm taking all the people that fit this criteria, all the people that fit this criteria. If I would add them up, I would just get the total number of people who are over 55. So the same thing works with probabilities. I can add across the rows or down the columns. So notice 0.14 plus 0.11 is equal to 0.25. 0.14 plus 0.52 is equal to 0.66. So 0.52 plus x would give me that 0.75. I can do a little bit of algebra here, subtract 0.52 from both sides, and I'll get x is equal to 0.23. And if I check it adding down the columns, that should work as well. 0.11 plus 0.23, sure enough, gets me that 0.34. Okay? Any other questions that people want to go over specifically?
So like, could that, like this kind of table be used on like given things, like given that the person is 55?
Here we go. Let's see. I think there's one. It's a good question. Here we go. It's a good question. We'll go over that right now. So we're going to go over to practice exam B. We're going to go to question 6. Okay. So here we have whether or not someone wants marijuana legalized, and whether or not they're a Republican. Right? So number 6 says, what is the probability an individual wants marijuana legalized given that they're a Republican? Right? So here we're thinking about the probability that given someone's Republican, what's the probability, and we'll just call this LM for they want marijuana legalized, or LM is equal to yes. Okay? So I'm looking at this conditional probability. I can't grab that from exactly from one cell on the table. But what I can do is say I can rewrite this conditional probability as the intersection of these two events divided by what I'm conditioning on. So I go back here and I say, okay, it's the intersection of these two, so LM is equal to yes and they're Republican divided by the probability of what I'm conditioning on, which is on the right-hand side of that vertical line, so that they're Republican. Well, now, what's the probability that they want marijuana legalized? Yes, and they're Republican, 0.15, divided by the probability that they're Republican. So Republican yes is 0.5. And I would get that conditional probability is 0.3. So you could have to find a conditional probability from the contingency table, right? And the key there is, you can rewrite that conditional probability as the probability of the intersection of those two things divided by whatever you're conditioning on, which is on the right-hand side. Yep, it's a good question. Any other questions that you guys want to go over for on exam A? Okay. Oh, okay. So here we've got the score in 4 different categories. We're wanting to find a mean, or the weighted score in this class, a weighted mean. Now, what you wouldn't want to do is, if you're just thinking about this as finding like what the mean score is, if I simply add these 4 values up and divide by 4, that's the way I would typically find a mean. One second, Chris, I'll answer your question in a second. So here, what I need to do is take into consideration some of these scores carry a higher weight. So when I look at my formula sheet, if I can scroll over here, here's my weighted mean examples, right? No, sorry, these are my regular means. Where are my weighted means? Here's my weighted means. Here's my weighted mean example. I'll multiply each outcome for x times its weight, add them all up, and then divide by the sum of my weights. Okay? So what that means here is I'll go and take 20 times 75, add to that 40 times 94, add to that 15 times 84, add to that 25 times 68, right? That would be what's in my numerator. And I'm just multiplying kind of across and adding them all up. And then I divide by the sum of my weights. My weights are kind of told to me to be right here. So I'll divide by 20 plus 40 plus 15 plus 25. And I do this, I believe I think I'll have to look at the answer key. I think it's 80.25, but that could be wrong. Well, I can do this. Let me calculate it real quick. So we do what? 20 times 75 plus 40 times 94 plus 15 times 84 plus 25 times 68. Oh, I was wrong. I remember this one incorrectly. It's 82.2 if I do that math. So when you say this document being available, you mean the one where I'm typing things in right now? Because these practice exams are available and the answers are there. But in terms of like me typing this out, is that what you're referring to? Okay, I don't know. If that is the question, I'll save what I have in here. I don't know if all of it will always make sense. But yeah, whatever. I guess wherever I stop at the end of the class, I can save that and then post that up there. I would think it'd probably be more helpful to just go back through and kind of watch the video on YouTube after it's posted than try to look at kind of what I've done here, because some of it might show up and some of it might not, and it might not be clear what goes with what. Because I'm really just doing it to kind of give you a visual in the moment. But yeah, I can post this. Any other questions that we want to go over here? Start on. No? Number 3 on exam A. Okay. 3. Oh, okay. So this is one where I think I have this in one of the YouTube videos I put up. But a lot of times what I'll do is if you were to calculate the mean incorrectly, then you're for sure going to get the variance or the standard deviation wrong. So we've got these fires height, weight. I think I asked you for their, I tell you the average height is 71.6. What's the sample standard deviation? Okay, so go to our formula sheet. We need our sample standard deviation, which is right here, S. Well, it's just the square root of the sample variance. So the sample variance is go through each value for the variable, subtract the mean, square it, add them all up, and then finally divide by n minus 1. Okay? So if I'm looking here, here's my height variable. I'll go through the very first person. So 69 was their value. 69 minus that mean of 71.6 squared. Then add to that the next outcome, 74. The deviation of 74 from that mean of 71.6 squared. Add to that, and then I continue to do that for each person all the way down to the very last one, right? So once I have all those values and I add them all up, because it's a sample, I'll divide by n minus 1 or 5 minus 1 here, so 4. Next, there's 5 observations, so n minus 1 would be 5 minus 1. And then finally, kind of, I need the standard deviation. Oops, I didn't want to delete all that. Well, I'll just type out the shorthand in Excel, right? I would then take the square root of all that, right? Or you can imagine this big square root sign over there. Now here I use this assumed true value. If I give you a value on the exam that's an assumed true value, like don't read into it. Like let's say the question before I asked you what's the mean height, and then I asked you, okay, assume the average or the mean height was 71.6. Don't read into that at all. I'm probably choosing this assumed number for reasons completely unrelated to what the actual value is, probably to make the equation a little bit easier to compute in the calculator, try to give you a little bit kind of a nice round number. Don't read into these assumed true values at all, otherwise they might lead you to like incorrectly, going with different answers on previous problems. Does that help with that one? Any other questions that anyone wants to see kind of work through? Let's start with those. So you can use Excel to do your math if you want to. I would say just make sure if you do that, you're very confident in your Excel abilities, because if you make little mistakes and you're not aware of it in Excel, you can get a wildly incorrect answer, right? So I would say make sure you're just as confident in your Excel abilities as you are in your calculator, like the ability to use a calculator. I mean, if you do use Excel, I would also say if you have extra time, I would always double check it by doing it by hand and using a calculator. But yeah, you can use Excel. So the only thing that you'll have to show your work on, so those multiple choice questions, I don't need any of your work. That final short answer question where it has a couple different parts, I want you to show me your work there. And you can do this by doing the work in Excel, doing the work in Word, typing it out like I am, or writing it down and then uploading just a quick screenshot from your phone or any other kind of video capturing device. If your computer can take the picture, you can take the picture holding it up and then just upload that for the short answer. I talked in the last section about I used to, I've done it where I've done more short answer questions and it kind of negates it because when you have no idea what's going on, you don't have the opportunity of maybe guessing or at least kind of getting close to correct because I can see your work and see you get no points because there's no work. But it also, allows me, if I have a few short answers to the harder ones, even if you make a slight mistake, I can still kind of give you some points for that work. So I tried to make that short answer part the one which I think is kind of more difficult, and I would actually want to see your work because I could give you some possible partial credit there. For the short answer part, I would expect some of the later stuff we talked about. So what it would be like is maybe I give you something like this. Like I turn the binary, so 17 through 19, I might just turn that into one big short answer question where I ask you for, I don't know, maybe the mean and the variance. The next question I ask you what's a probability exactly 10, and then what's a probability less than 14, right? So I kind of contain, I just want to see more of your work from the binomial part, or I take some Poisson example, I create a few questions based off of that, and I make that into like a 3 or 4 part short answer question. Or I guess I could take even, I'm not going to do this, so I'm not sorry, but I could take like the contingency table part and like turn these questions into kind of a short answer where I want to see your questions. So yeah, I'm not going to ask you like any question that looks wildly different on that short answer than what you're seeing on these practice exams. It's just kind of converting some multiple choice questions into a short answer question. There's no, yeah, wouldn't expect like any theory. Like I said, someone I think asked earlier, looking at those old online quizzes, those are good questions that, to study, that you would see something similar to that in the exam, maybe a little bit harder than some of them. Anything that we'd see on these practice exams, you go back through, the Connect homeworks, probably a little bit more, or the Connect homework, I guess, a little more difficult. The Excel homeworks, you could review, I'll get up the answer key to Excel 2 after class today. You could review, I guess, some of the contingency questions from that Excel homework. Although you've got 2 examples here in the practice exams of questions that look similar to that. But yeah. Other questions? Let me look at practice exam B real quick. What else can we work through? So I'll talk through this one and give you, yeah, I do want to go through this one actually. So I'll go through this pretty quick. But if we start on question 17, these binomial examples. So let's say I've got 10 credit card customers. The probability any one customer carries a balance from month to month is 40%. And I'm interested in what's the expected number of customers who carry a balance. Well, I either see someone carry a balance or I don't. So I've got a success failure. The probability I see that success or someone carrying a balance from month to month is probability of 0.4, right? 40%, probably of 0.4. And I've got a number of trials, which is 10 people I'm looking at. So the expected value, if we look at our equation sheet, our binomial equation formulas are over here, these bottom 4, right above the Poisson. So if I want to find the mean, it's as easy as the number of trials times the probability of success. So here, if I want to find the mean, that's just n times p. Well, my n is, I have 10 individuals. My probability of success is the probability they carry a balance is 0.4. It's as easy as multiplying those 2 things by each other, right? So hopefully, if you've got a question like this and you can identify that says like, I've got a capped number, like a total number of trials. I'm looking, I've got the probability of success for any one of these trials is the same, 0.4 or 40%. Very easy to then say, okay, here's my equations for the mean for a binomial and the variance for a binomial. So 18, if I want the variance for the binomial, it's simply n times p times 1 minus p. So there it would just be n times p times 1 minus p, or, oops, not 8, times. So 10 times 0.4 times 1 minus 0.4, which I think is 2.4. Right? And then if I wanted not the variance, but the standard deviation, the only additional step I would do there is take the square root. Right? So that could be another question you could ask. Yes, is the standard deviation, which you're kind of reminded here is just the square root of the variance for a binomial. Okay. What if I wanted the probability of exactly 4 customers carrying a balance? Well, I've got n is 10, p is 0.4, my x is now 4, and I want the probability of exactly 4 customers. So I can use this binomial formula, plug in 10 for n, 4 for x, p was 0.4, and that's just a matter of plugging and chugging, right? Now, which of these can I rule out right away? I'm looking for a probability. So right away, I know that 1.2 can't be it, right? I have to be somewhere between 0 and 1. I also know that the most likely outcome is 4, right? And so having a low probability for seeing exactly 4 doesn't seem right. It's probably going to be either A or B, right? From there, it's just a matter I have to go ahead and plug everything in. You know, at that point, it's not a lot I can show you, but 10 factorial divided by 4 factorial times 10 minus 4 factorial times what? 0.4 to the x. So our x was 4 times 1 minus probability of success, or 1 minus 0.4 to the power of n minus x, or 10 minus 4. And then it's just a matter of kind of plugging this into our calculator. I believe if you do, you get approximately 0.25 here. Okay. Any questions on that one before we keep moving? Actually, I can double check that, but I'm pretty sure that's what it is. So we have what? 10, 10, 10, 10, 7. 0.4 to the, oops, 4. That's 0.6 to the 6th. Yeah, we get just over 0.25, right? So the second decimal rounded, we would get 0.25. Okay. Once again, make sure that you can find that factorial button on your calculator if you haven't already. Or I didn't even use mine just now. I just thought about like what cancels and remember that this is 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1, right, for 10 factorial. What if I wanted the probability of at least one customer carrying a balance? Well, the probability of at least one would be that x is, and I'll write this out the way we do by hand. So where's my greater than there? There we go. The probability x is greater than or equal to 1, right? That's the probability of at least 1. Well, if I wanted to find this, I have to go every outcome that fits this criteria. So the probability x could be 1, plus the probability x could be 2, plus 3, plus 4. Every time I want to find one of those probabilities, I have to use this binomial equation again. Well, that's going to get really tiring. But if I think about this as event A, then I know that using the complement rule, I can rewrite event A, right, as 1 minus its complement, or kind of said differently, the complement would be 1 minus the event. So what would the complement of this event be? X is less than 1, which is the only probability that fits that criteria. What's the only outcome that could be less than 1 here? Well, if it's a discrete random variable, the only probability is that x would be equal to 0. Right? Now I only have to use this binomial equation. Oh, where did it go? One time, n will be 10, p will be 0.4, and x would be 0. Once I plug all those values in, it'll spit back out at me a probability. I'll then subtract it from 1. Okay? If I do that, I believe I'll get 0.99. But here's one where I should at least be able to guess between 2 here. Because think about it this way. If I want the probability of at least 1, first of all, what's the most likely outcome? The mean. So the probability x is equal to 4 should be the most likely outcome. The next most likely outcomes would be 3 and 5. The next most likely outcomes, 2 and 6. Notice all of those value outcomes are included in this criteria. So I know that the most likely outcomes are kind of in this range. So this probability should be pretty close to 1. Okay? Now, if I think about that ahead of time, I think, okay, this should be pretty close to 1, because the only outcome that doesn't fit this criteria is that x is equal to 0. I know this is going to be pretty close to 1, so A or C here are really the only options I should be thinking about. Okay? And if I had forgotten to subtract the probability, x is equal to 0 from 1, and I answer 0.01, well, that doesn't even make sense if I write down originally what I'm actually looking for. Okay? Any questions on that, or any other questions on the exam? On any practice exams, or any questions about the exam specifically? I'll wait for the chat, see if there's any questions that come up here. You okay with this? Okay. Probably going to stop there unless there's any questions that someone wants to see through kind of real quick. Probably don't have enough time to go through a Bayes theorem problem. I put up a YouTube video of how to kind of work through one of these. You could watch as well. So 14 through what? 16 covered. Except done a couple Bayes theorems problems. We went through some of this. Did some contingency table stuff. I would rewatch maybe the video that I posted of this. I worked with some contingency table problems for practice exam A as well. So it just looks similar to this, but a different example. Look at those online quizzes for additional problems to work through if you're looking for more. And is there anything you should focus on that's not? So one thing I would review that's not on the practice exam is just kind of what a correlation coefficient means. So not necessarily how to calculate one, but knowing that they're unitless, it allows us to compare across variables. And so that if I saw a correlation coefficient closer to 1, that would represent a stronger positive relationship between two variables. And if I saw a correlation coefficient closer to -1, that starts to represent a stronger and stronger negative relationship between two variables, right? And think about how, let's say I had two different examples. So one, I had height and weight, and the correlation coefficient is 0.4. The other one is age and income, and the correlation coefficient is 0.9. I could then say the relationship between age and income is stronger than the relationship between height and weight because it has a higher correlation coefficient. So yeah, that might be a good thing to kind of brush up, and I don't think really popped up on the sample or on the practice exams. All right, if there's no other questions for me, I'm gonna let you guys get going. I'll see you on Wednesday for those of you who want to come to class in person. Good luck on the exam. Like I said, you can start at any time today or tomorrow. You have an hour and 20 minutes once you start. It closes at midnight tomorrow, which means you need to start it before 10:40 at night, right? So if you want the full time, okay? Other than that, good luck, and I will see you back in class on Wednesday.